Hello students, welcome to AriserTalent. I'm your maths teacher Arpita Sharma. Students, we are discussing probability chapter, and in that chapter I have given you one question which was this question related to bulb lots, and we are having some defective ones, some normal ones, and we are drawing a random bulb from that, and then we have to find out the probability in the second one too. Okay, so there are two part 1, part 2. I'm repeating the question. A lot sorry, a lot 20 birds, a lot of I've corrected it yesterday too, so make it a lot of 20 bulbs, right? Contains 4 defective ones. One bulb is drawn at random from the lot. What is probability that this bulb is defective? So you have to know the probability that this bulb is defective. So defective probability you have to find out. Now the second part is, suppose the bulb is drawn, this first activity has been done, so bulb has been drawn, so remaining bulbs 20. Okay, now the bulb drawn is not defective, so it's normal, it's good, okay, and is not replaced. Now it's not replaced, it has been drawn, so number of bulbs remaining are 19. We have discussed it. Now one bulb is drawn at random from the rest. Now again the same process is being done, but in this case, in the first one, we have talking about having drawn a bulb from the lot of 20, now that reduced to the lot of 19, right? Here that was 20 bulbs, here that remained with the 19 bulbs, here that was 4 defective and 16 normal, here that was obviously 4 defective. Why 4 defective? Because the drawn one is supposed to not to be defective, it's normal. So 4 defective because defective has not been drawn, and now 15 because 19 minus 4 is 15, so 15 is what? Corrected ones or normal ones, right? So students, now I'll talk about the solution part. So students, that is clear for you guys. For the first condition, we have to do it for the first one and for the second one, because number of total outcome and the favorable outcome will change in each and every case, the first one and second one, because condition differs here. So we'll go with the first one, and here the number of total bulbs in lot is equals to 20, and that is also your NS, right students? This is also your NS. Why NS students? Why NS? Because the number of total lot, the number of lot is 1, the number of total bulbs will be equal to the number of total outcome. You may pick randomly any bulb, na, so that's why you'll be having 20 total number of outcome. Now we'll talk about the favorable outcome. Now the defective ones are defective bulbs in lot equals to 4, right students? Now we have asked in the question that what is the probability that the bulb is defective? The bulb is defective. So if the bulb is defective, we have to talk about only the defective ones, and the defective ones are what? Only 4 bulbs, right? Understood? So there is no debate about that. So coming back to our question here, defective bulbs in lot equals to 4. So may I say this, that students, if the defective number of bulbs are 4, then that will be equals to NA. If the A is the event, okay. Let us assume that event A is the event of getting a defective bulb. right or wrong, right? Right. So this is an A and this is an S. Now PA, or what we else can we say that probability of getting a defective bulb, a defective, which one student? Defective bulb, right? Is equals to what? How we denote it? PA, because we have assumed that event that have occurred is equals to A. So that will be PA and that will be equals to an A by an S. And this is what? This is our favorable outcome. Yes, favorable outcome. And this is our total outcome. So total outcome is 20, favorable outcome is 4. Right, my dear students? Now that will be PA equals to, just put the values here, right? So 4 by 20 and here you got it like 1 by 5 and this is your, what we call it, answer. Answer of part 1. Yes, done with that. So now what you have to do, just copy it students so that we can move forward to the next question or the next part of this question basically. Okay. So the second part, ready for the second part? Have you done that? I've told you to do. Okay, whatever. Now, again, total bulb in the lot 19. Sorry, 20. Given, what is given in that question? In the second part, it's given, then one bulb has been drawn. So, given one bulb is drawn. So, remaining bulb equals to 19, isn't it? One bulb has been drawn, so remaining is 19. Now, this is also given student that the bulb is not defective. Bulb is not defective. Since the bulb is not defective, therefore what? Therefore, total remaining defective bulbs. Now, 0 defective bulbs have been taken out, so the remaining bulb will be, okay, 4. So, total remaining bulb, meaning defective bulbs in lot is equals to, this is 4, right? Now, in question, students, you have to know the probability that bulb is not defective. So, you are not talked about this 4. You have talked about, this time you have talked about the normal ones, not defective. So, not defective bulbs will be equals to how many total remaining bulbs? Remaining bulbs minus defective bulb, that will be non-defective in that case. Okay, so if that's so, then we'll be having that is equals to, remaining bulbs are 19, defective ones are 4, so that will be 15, isn't it? So, not defective bulbs are 15. 15 bulbs are non-defective. Okay, and that will be also what? Your NS in this case, right? And the total outcome, total favorable outcome, or you can write it is equals to total, or just says favorable, right? Favorable outcome. In this case, in the case number second, and now you can call it N B. If the event, this event is B, okay, and mark the second also. Event B we are assuming. Okay, so this is favorable outcome and B. Now total outcome, but total outcome here in this case, in the case number second, will be equals to remaining bulbs, remaining number of bulbs is equals to NS, and that is equals to 19, right? Implies that PB, or probability of getting a non-defective bulb, is equals to PB equals to NB upon NS, and in this case NB is equals to 15 here and NS equals to 19 here. So student, this is something your answer number 2, right? So now what you have to do, just note it, then we will do another interesting question. Noted? Okay. So the next question is, a card is drawn from a well shuffled deck. Now I've told you this session gonna be very interesting because we are having cards here, dice here and whatnot. So a card is drawn from a well shuffled deck of playing cards. Find the probability of drawing a face card. Now note this, a face card and a red faced card. So we are getting two things here, a red card, a red faced card and a faced card. So we have talked about these cards, right? And if I'll talk about this face cards, so I've told you or not. Okay, we have talked about honor cards, we have talked about honor cards. Okay, and we have talked about court cards also. Students, face card is nothing but these are the court cards basically. So if you remember what I've told you, what are the face cards or I'll say court cards, that was this first one and this was the second and the third. Let me first. Yes, these three cards, they're having face, right? These three cards, they're having face, the 1, the 2 and the 3, right? So these are three face cards. Now, if I'll take out all these things and I'll be just count them, just three from spade, 3 from, so I'll just count it the 4 categories and I'm having 3 in all. So face card will be equals to what? 12, right? Now if I talk about the color, this is for normal. In normal condition, face card will be equals to what? Total face cards. Total face cards. 12. Now if I'll talk about only red faced card, red faced card. Now red faced, we are having two cards, sorry, four suits in that, two black suits and two red suits. So black suits are eliminated, so only two red suits have been left. Now you are having only two suits here. So 2 multiply by how many in each? 3. So that will be 6, simply half of that. Okay. So any confusion in that? So you'll be having 6 cards, 6 red faced cards. So this is about the counting of cards. So you'll be, if you are counting with this, you'll be having this jack and that king, right, and that king also, and then this queen and this queen. No, S's are not included in that. So just count, you can count that 2, 3, 4, 5 and 6. So 6 red faced card. Okay. So clear with that thing? No doubts in that? Okay. I'm just going to rub that. My basic motive was just to make it very familiar to you guys so that you can visualize what question you are doing, how you are doing this, why it is so a face card. It's very simple, na? If you are seeing a face in that card, that is a face card. Okay. So there is a solution part of that. So the first one, we'll talk about the first one. Should we? Okay. The first one. And the first one was what? Face card. A face card probability. And we'll call it as event A. So saying the card is drawn from a well shuffled deck of playing cards. Now, how many cards we are having in one card set or playing card set? We are having 52 numbers of your cards. So, total outcomes equal to total number of cards. That will be equals to 52, isn't it? That's so simple. We know that. We have studied that we are having 52 cards in total. Now, this is what about total outcome. Now we are having face card, total face cards, or we can say total favorable outcome, or we can say favorable outcome. Favorable outcome is what? Getting a face card is equals to total face cards in playing cards. That is equals to 4 multiplied by 3 in each is equals to 12, and that will be called as favorable outcomes. How will denote it? N of A. And what that? I can write it here. That will be known as N of S. Now, this implies that probability of getting a face card, that is event A, okay, is equals to NA by NS, and that will be equals to NA is what? We have calculated 12 and NS is 52. Now can we just cut it by 2? That will be 6. 26 again by 3 times, 13 times. Sorry. So students, this is 3 by 33 is what you'll answer. Answer number 1. Now student, NS will be the same. NS will be the 52 in that case also. NS will be the 52. Now what the question number 2 is telling us, or part 2 of that telling us, a red faced card. Now I am talking about a red faced card. Okay. So in this second one, a red faced card, probability, we'll just name it as event B. Okay, can we do that? Event B. Now, total outcomes are same. Again, you can write it. Okay, now I am talking about favorable outcome. Favorable outcome. Okay. So favorable outcome are what? Outcome which are supposed to be a red faced outcome. So red total red face cards, total red faced cards, and now the total red faced cards are what? Equals to how many? That was 12. So what we have to do, just half the 12, or you can just say that we are having 2 lots of 3 cards in each lot, right? Or each you can say suit. So that will be simply 12 by 2, and that will be 6, and that is equal to your NB. So in that case implies that probability of that event B, which is getting a red faced card, is equals to NB by NS, which is equals to, students, what? 6 by 52. Now 6 by 52, that means that will be 3 and that will be 26. So 6 by 26 is what you call as your answer, right? This is your answer for the second one. Okay, so noted the first one. Now note second one also, so that we can move further. Okay, noted this. Okay students, so this is enough for today. You have to do much more questions on that probability. So what we'll do, we'll meet in our next lecture and we'll do some practice with new questions. Till then, take care students. Bye-bye.